Alright guys, let's do the second knapsack problem. This. Okay. It's an e-knapsack. So let's let's do this. The problem statement is there are n items, right? Which are numbered from 1 to n. Each item I has a weight of wi and a value of vi. So I will decide to choose some of the n items and carry the home in a knapsack. The capacity of knapsack is w, which means that the sum of the weights of item taken must be at most w. Find the maximum possible sum of the values of items that Tarok takes home. It's very similar to the previous one, right? What's the difference in this, the previous one? Do you have any idea? So let me do this again. Right. Right, this is how we do it. And after this initialization and all, we have a dp of n comma 0, right? Or we can say because it's an knapsack problem, so w plus 1 comma 0 here equal to 0 I is less than so here y plus right area of 0 is closer outside the 2 of 1. 1 10 GB of value. Yes. Different video. It should be right here. Where I am getting runtime errors. Why I am getting runtime? Why it's correspond means okay, so it's saying like it's a perfect code, but okay, so okay, so this was the problem, guys. You can understand. Let me understand also this. I don't know what's the problem that was. So it's saying like okay, it is saying W constant of knapsack capacity is 10 to the power 9, right? Capacity is huge here. But in previous code, this is long. If you try to do, if we are trying to do the long in this case, like we are asking C++ to repeat a array of size 10 power 9. Okay. So it's a space failure. Is long is 8 bytes. So 10 to the power 9 into 8 is 8 GB of RAM. So it's a huge problem. It still limits this. Okay. 1 GB. This will cause memory limit exceeded crash. Time failure is your previous time was NW. Alright, loop iteration. Alright, here TLE also. The method flips the DP state. To solve this, we must look at the constraints that are small. Right? So notice the maximum value of a single item is very small here. This value. Okay, since there are at most n items, the maximum possible value could ever receive is this 10 power 5. So instead of capture T, we should go for the value. And option weight, what is the max? Instead of asking for a backpack of weight W, what is the maximum value I can get? We should ask this question, which requires taking 12 million weights increment. Now we have to flip the question upside down to achieve exactly a value V. What is the minimum weight I need to carry? Alright. So which only requires this 100,000 value increments. Okay. It's 10 power 5. So new dB will be dB of size V, represent the minimum weight required to achieve exactly a total value of V. So dB is 0, 0, 0. It takes 0 weight to get 0 value. Alright. Every other dB of V is infinite because we haven't found the way to achieve those values yet. Alright. And now recurrence relation would be for each item I, you loop through all possible values backwards. Alright. If you choose to take item I, your new weight is the weight needed to get V minus Vi. If you choose to take item I here, right? So your new weight is to weight needed to get V minus Vi value plus the weight of the current item or Wi. After building this DB array, assembly scan the highest value possible down to 0 and the first value V whose minimum required is. So after building this DB, you simply scan for the highest possible value, which is 10 to the power 5 down to 0, and the first value V whose minimum required weight is less than W is your answer. Alright. So we can, without doing the code, we can write the code also. Alright. What we can do is, we're saying don't do this. We have to go for the max value, right? Alright. So what is the maximum value we can get? So maximum value Vi 10 to the power 3, and let's say each item is 10 to the power 3, then how many items are there? 100. Now 10 to the power 5. Right? So 10 to the power 5 we can initialize it like 1 E5 like this, right? That's how we initialize it. And this is for enough infinite is there now. Right, so one is 60 degrees. You can go to that, alright. Initialize the value, but dp of 0 is 0, right? Okay. What we are doing, we have to find the value of I plus weight, right, and minimum weight for this. You have written what? For W. Okay. For enter equal to 1e5, right, minus 1 I greater than equal to 0 minus, right, f equal to I less than equal to W. Right. See out I, right, and brackets. This is good now. I want some marks to I think I would now. Yes, alright. So J is equal to, what should we have instead of J is equal to this? Right. J should be what? We are coming from highest value, right? What is the optimal area? Right, always at this offer. Next value, right. Next value minus 1. Divide, alright. And I think I have an idea now. Alright. Value 5 plus 5. Then G is equal to, right, let's do this. Into max value. new file is format Maxwell and it's Maxwell minus 1 verify that. I think we are good now. Why there is a problem or more? Alright guys, let's do this now. We have comparison error now. Y A0 and what are we working with, guys? We can't go. Right, it works right now. It only took this much more 400 KB. It's very less than 1 GB and this 6 milliseconds is very less than. So score is 100 now in this case. Score is 100. So we are moving out, guys. We are moving right, and then again now we will go for next problem. We were working through in hexagon. Right, now next is the target symbols. It's a lead code problem. Alright, we can do this. So what is are we working with? Let me be back in 2 minutes. I will have some water. Then I will be back, guys. target sum. Let me understand it first. So you are given an integer array which is nuns, an integer target, right? Now you want to build an expression out of nuns by adding one of the symbols plus and minus before each integer in nums and then complete all the integers. Alright. For example, if nuns is equal to 2, 1, you can add a plus before 2 and a minus before 1 and compare them to build an expression plus 2 minus 1. Return the number of different expressions that you can build which evaluates to target. Alright. So different expressions, number, so you have to count, right? Alright. Which should go for target, alright. So guys, let me take this, or we can say, let me take this from here. This is the question, right? Let me take this from here to here. Alright. View. Right. And one more thing I can do. Alright guys. It's looking good now. So question is this. Wait. We have to see that one, guys. It's important. Alright. Alright, we are good now, guys. We have more space now. No, yes. So you are given an integer array and a nums target, right? So we have to add some signs before every integer. Then we check if it is equivalent to that or not and count that. So let's say so in DB problems what we do is first we bring in the index form. So it's already array, so it's already index. Then do whatever we can do on that particular index, right? So target is like capacity, then compare those actions like whatever. So I am saying we can make target as a capacity problem, right? Capacity. No, no. So yeah, so it's let's say we can take example from here also. Right, so let's take this example, right? So we have very nums here, target is 3, output is 5. How you can see that there are 5 ways to assign symbols to make sum of nums 3. So we can at this index we can give 1 minus plus plus like this. So not so it's a 5 ways. Okay. So this, let's say we have this index, right? 1, 2, 3 index. Either we can add plus here, either or we can take minus here, right? Index, then what do we do after? If we are doing plus, right? So what we are doing? We are adding no. We are adding 2 so target less is 3. We are making of 1, so we have to minus from target, right? Which becomes 2. And if we are subtracting from it, so we are adding to target, right? Yes. So if we add, then target minus value of I, right? If we subtract, then target plus value of I, right? This is the new target here. And if we are target equal to 0, somehow then we return 1, right? Return 1, else return 0, right? So what we do, then we add these both, whatever number this returns and whatever number this returns, we add them and return. I think this is how we can do it. Okay, so let's take this example here. Let's take this example, which is 1 1 1 1, and target is, or one some very creative example we can take, right? What example we can take is 3 is the target. We have 1, 2, 6, right? 9. Let's see how it is. So plus 1, plus 2. Let's say what if it does not happen? Let's say plus 1 minus 2. It will not, it will 0. So how do we count them? Count is important, right? Count is important. And one more thing we can say, let's say we have target, right? If we are here to apply DP, target 3, 0 1 2, 0 1 2 3, 1 way to get 0. Is there any way to get 0? We can check that also, alright. But it's target 1. We have ways to get 0. If we are moving from 0 to 1, let's say it was 3 minus 3, we can get 0. But we cannot get 1, right? Right. Right, so let's do this for recursion first. And n is equal to size or their constraint, all well are in the limits, right? So let's say all are thousands, and some of the nums I also in the limits. So right, so now problem with limits. And of n is equal to nums of size, alright. Target we have. We can define a function. It can take nums of nums. It can take the target. It can take. We will see what it will take more. If target is 0, return 1. But how here if target is 0, if here target is 0, then we have to return 0, right? No, target can be negative also, right? Okay. Okay, so we can think about it more. And to take, we can say add is equal to nums of I, alright, into I. We are adding that plus we are adding this value total, right? Total. So we can take total also. Total. Then if total is equal to target, we can say total return 1. We are adding what? We are adding this, then f of if I greater than equal to window size return 0 from there and try governance target I plus 1 comma total plus nums right. And so if we are subtracting nums comma target comma I plus 1 comma minus nums of I here, and after all of it we have to return plus subtract, and we don't have to do this also, we have to return f of nums and target 0 comma target is totally 0 also, right? How well this can go, guys? Have any idea? So target is missing. we have to put signs to all of them first, right? Right. Okay. Okay, so we have called add, we have called subtract. Add all of them here. So then if I is equal to dot size minus 1, here, and what will do? And total target, then we will return one. What do you say? This is still no zero output. Can we do this from DP, guys? Like how? Should we take 2D DP in this? Right? Target by number of elements in array. Like that. What will be the size of this? We have target which is 3, 0, 1, 2 and 3, and we have the elements 1, 1, 1, 2, 3, 4 and 5, right? Now for 0, can we get 0? We can traverse these elements, plus minus, plus minus, plus, whatever. So there is little problem we are facing, guys.